Well, welcome everybody. It's so great to have so many people join the webinar today. This is our second webinar of our series of webinars that we've been launching. Today we're going to talk about bioacoustics, specifically ecoacoustics approaches for monitoring sites, habitats, and species. So a little bit about Biodiversa Plus to those who haven't heard of Biodiversa Plus before. It's a European biodiversity partnership supporting excellent research on biodiversity with an impact on policy and society. It has several thematic groups, one of which is Work Package 2, which focuses on biodiversity monitoring, and its goal is to set up a network of harmonized schemes to improve monitoring of biodiversity and ecosystem services across Europe. So this is kind of a schematic on what Work Package 2 looks like. There are several goals from priorities and indicators of biodiversity monitoring to harmonization of protocols and methods to building a network of national biodiversity monitoring schemes. So we are the task leaders of Task 2.3.1, which focuses on novel technologies and approaches. Today, we'll also hear from one of the co-coordinators of one of the biodiversity monitoring pilots. One of our milestones and deliverables as task leaders of this novel technologies and approaches task was to, we launched a survey last year to Biodiversa partners to get a understanding of the state or level of deployment of these 5 novel technologies here on the figure. We wanted to understand the state of their deployment on these 5 novel technologies for biodiversity monitoring and what sort of taxa they were targeting, as well as essential biodiversity variables that they were targeting with these different novel technologies. We also gathered some information on the sorts of challenges and constraints they were facing in reaching higher levels of deployment within these novel technologies. From this survey, we published a report which explained these results, and from this report, we've launched a series of capacity building webinars where experts and partners can share their experiences using these novel technologies for biodiversity monitoring and talk a little bit about their experiences and challenges with this. So the agenda for the webinar today is, after I'm done speaking, we'll hear from Carlos Abrams from Baker Consultants and Nottingham Trent University. He is an experienced ecological consultant and ecoacoustics expert with over 30 years of background in biodiversity monitoring and sustainable development, and specializes in using sound data to assess sites, habitats, and species, providing actionable insights for conservation and environmental management. After this, we'll hear from Jamie Alison from Aarhus University, who is a co-coordinator for one of the pilots, the ABMS pilot for Biodiversa Plus in Work Package 2. And then we'll have a sort of open session, questions, debate, discussion session where we can, where anyone, the audience, you guys can ask questions to the presenters. You can also do this in the dialogue box, in the question and answer box. You're welcome to type in your questions there. But we'll leave the bigger questions in the comments for this last section. I think that's it. So yeah, thank you everybody for being here, and I'll give the floor to Carlos.
Okay, great. Thank you very much for having me. Maguiña, thank you for the introduction. So I'm Carlos Abrahams, based in the UK, not part of Biodiversa Plus, but fan of the scheme. I'm an ecology consultant and been working on environmental impact assessments and conservation projects in the UK for the last 30 years or more. and increasingly do more and more of my day-to-day work is on the use of acoustics. I have a research background in there, and I've also developed or tried to develop good practice guidance for users to take on and make use of acoustic methods within their monitoring as well. And I'll be trying to talk a little bit about the guidance and some of the research as we go through today. So I'm not going to be talking about the hardware that we use or the software that we use for collecting sound and recording it. That's a talk for another day, probably. But I just want to start with just by playing you a sound and saying this is the sort of data we can collect in the field, whatever environment we're working in, and we can listen to those, view them on screen in terms of recorded sounds, and then try and turn that into data that we can use within ecological studies, whatever sort, and especially for capturing data from the field that can be archived and stored for a long time compared with other data, integrated with other data sources as well, and made use for long-term monitoring, especially at local or transnational scales, depending on how we want to carry out the work. But let me play you a sound to start with. Okay, so we've got at least 3 species present within that. We've got curlew, Numenius arquata, at the start, red grouse right at the end, and a bee. I don't know which species of bee it is, flying around in the middle. And we can use recorders to capture sounds like this from the environment, use it to find out what species are there, what behavior they're performing, whether it's producing breeding calls such as this, or contact calls, or flight calls if it's birds, and the same information if it's bats. Use that to understand their presence and the use of the landscape, and also potentially use it to link to population sizes and other really useful pieces of information that we can then use as conservation managers to help conserve these species and the habitats they live in and the sites that we protect and to look after them. So Maguiña's already done this, but so I don't need to go over the Biodiversa's work in terms of developing and monitoring new technologies, but the report, again, I recommend it to you. It's a good survey of practitioners and has some useful information there on how bioacoustics and other technologies are currently viewed by conservation managers and how much they are used. And there's a few other reviews that have been published in the scientific literature, such as Larissa Sugai. If you look up her work, she did some good reviews a couple of years ago in terms of practices and use for different habitats and different species groups and how we can use those. So I just want to show you one other graph that was a result of the Biodiversa report. Shows that the green is showing actual methods that are currently used by Biodiversa partners at the moment, and you can see that no surprises that we mostly use bioacoustic approaches for mammals, and I bet bats are 95% of that. Some other mammals such as deer and other species might be in there as well. We use it for birds quite a lot. Again, no surprises there. Quite a high proportion of fish use here, which surprised me slightly, but maybe that's acoustic tags rather than actually recording fish sounds, and then some use for terrestrial invertebrates, orthoptera, so crickets, grasshoppers, and those sorts of things. But you can see that pretty much nobody uses it for amphibians and reptiles, even though we have some very vocal amphibians, especially within Europe, which we could use this for. And I'm currently doing a project in the UK looking at nutterjack toads, Epidalia calamita, and pool frog, and seeing whether we can use acoustics to monitor those. And then aquatic invertebrates. nobody's using it for that anymore, which is potentially a shame, because sound is a really good way to survey for aquatic invertebrates. Within the UK, we have something like 60 species of water bugs and about 600 species of water beetles. And as far as we know, those all produce species-specific sounds. They stridulate like little underwater crickets, and we can record those using a hydrophone and use that to monitor and survey for those species. So there's potential other applications there that could be really easily, well, I say easily, fairly easily implemented and rolled out and used as a very valuable source of ecological data for us. So the environment and all the things that live in it produce sound, whether that's humans driving cars and flying planes, or whether it's birds, bats, freshwater invertebrates, invertebrates in the soil, wriggling around and producing sound. And we can record those using equipment that's freely available these days, lots of potential sources for that, and make use of the data that's recorded on there using analysis approaches that are becoming easier every year, and use that as a really good source of ecological information. There's lots of research that's out there, and want to talk about how that might be transposed into applied practice by conservation managers such as yourselves. So if you look at the scientific literature that's been produced over the last few years in bioacoustics, ecoacoustics, whatever you want to call it, it's taken off like a space rocket. Yeah, from pretty much nothing 10, 15, 20 years ago. The electronics and digital revolution that's gone over the last few years has enabled new equipment to be developed and new analysis techniques to be built that allows us to use that within research. And so, especially in North America, South America, parts of Europe, other parts of the world, there's been a lot of scientific research that's gone on. A lot of that scientific research has not yet made its way into conservation practice. There's good reasons for that. Going back a few years, the kit was quite expensive, and the analysis approaches for taking those recordings and turning them into data were quite complicated and had quite a steep learning curve. But things like Merlin and BirdNet and Kaleidoscope Pro software produced by Wildlife Acoustics, for example, have made that data analysis approach much easier. And so really we should be picking up on the research that's been done and using these methods within our conservation practice. So great research. Not a lot of guidance has been produced, though, to allow conservation practitioners to start using those methods. And so the lower graph with all the coloured blocks shows the number of Ecoacoustics practitioner guidance documents that have been produced in the last 10 years. And there's probably some I've missed here globally, but you can see that there is something like 10 different pieces of guidance that have been produced. And in fact, if you look at this one, there's lots of green blobs on there for bats. This is the same bit of guidance that's just been updated year on year. And so actually the number of guidance documents that practitioners can take off the shelf, read, understand how to apply ecoacoustics methods within their own practice and on their sites is not really out there yet, although it is coming steadily. So what I want to do is just run through some different species groups and habitats just to highlight a couple of issues here. So the two areas where we do have good research and good practice development are in the oceans and the seas, where marine acoustics has been well established for a number of decades, and also within the world of bat survey and monitoring. We've been using bat detectors of various sorts for the last 20, 30 years, since Donald Griffin found out that bats echolocate. In the UK, we have had lots of BAT guidance produced in terms of how surveys should be undertaken for environmental impact assessments or for conservation management projects. And so we had the BAT Workers Manual go through various different iterations from 1989 to 2004. And then the BAT Conservation Trust have produced a guidance document on good practice guidelines for professional ecologists here, stating how we should do BAT surveys, what equipment we should use, what times of day and night we should do surveys, how much survey effort we need to put in for a proper scheme. And that report, big document, if you're not seeing it, you can download it for free from the BCT Guide website, and I recommend you do. It's been initially produced in 2009, then 2012, 2016, 2023 has been updated. So we're currently on the 4th edition of that one, and no doubt in a couple of years there'll be a 5th edition coming out as things get updated. So Bat Conservation Trust have done a great job in the UK of producing Ecoacoustics guidance for that particular species group. Within Europe, those people who work on bats will know of the Euro Bats guidance, technical note 5, I think it is, in terms of survey effort. That was originally produced in 2010, 2014, 2017. So again, has been updated fairly regularly, and there's good guidance out for there. One interesting feature to point out in terms of both of these is that the UK guidance especially has shown an increasing reliance on evidence base for its survey recommendations. So it's taking greater and greater recognition of the scientific research that's been done in proposing these survey methods that are used. And especially the new one, there has been an increasing reliance in the previous and the current editions of that, an increasing reliance on the use of static acoustic surveys. So passive acoustic monitoring, bat detector boxes that we stick out and leave in the field to do the recording remotely, rather than people walking around with bat detectors. As that technology has become more available and has become more used and has been tested in the science, it's been found that actually you're better off, generally speaking, using static surveys to survey for bats rather than relying on having to have people in the field. The information that you get from the two approaches is different, complementary, but generally you will get a greater volume of data in the first instance, and probably greater coverage, just because you can stick a bat recorder out and leave it there for a week or a month, rather than relying on somebody having to go out there night after night to do walk around surveys holding onto a handheld piece of equipment. And that approach has been shown for birds and other species as well. So it's a general direction that we're increasingly relying on passive acoustic monitors that operate remotely, generate large data volumes, which can be problematic on one hand, but we're increasingly able to deal with big data within ecology using new machine learning methods, for example, to analyse the information we get. So bats, I'm not going to talk much about. Birds is an area where I started using bioacoustics with some work on capercaillie, big grass species up in that's present in Finland and in north of Scotland as well. I organised a conference back in 2017, 2018, I think it was, and produced a draft bird survey protocol within a publication within the UK, and that went nowhere for 5 years until the equipment started to get better and the algorithms came along, and then in 21-22 new bird survey guidelines came out within the UK to set out how professional ecologists should do breeding bird surveys or wintering bird surveys, especially in relation to proposed development. That had a short paragraph on the potential to use acoustic methods within bird surveys in the UK. So I phoned them up and rewrote the sections. So within the UK now we have quite a detailed methodology. You can see the sections in the green text on the right hand side that provide an evidence-based protocol for using acoustics within bird surveys in the UK, and sets out there how long we should record for, what sample rates we should use, and what times of year you need to stick the recordings out, and what sort of density of recorders is appropriate to use here in most cases as well. So that's available at birdsurveyguidelines.org. It'd be nice to see that sort of approach rolled out in different countries around the world as well, across Europe. The reasons for doing that are not just to save the legs of ecologists and stopping us having to get up too early in the morning, but because it provides us with really good data. Following the guidance that we produced a couple of years ago, we did a short review of some commercial bird survey projects that we worked on in my company, and compared traditional walkover bird surveys with acoustic bird surveys. And all of the species listed in this table were those species that were recorded only within the acoustic bird surveys. And they are coloured by whether they are red or amber listing under the birds of conservation concern. So these are high priority bird species which were all missed by traditional bird surveyors going out to the work. So if you are trying to build up a good picture of a bird assemblage within a site for conservation reasons, or to work out what the impacts of development are, then if you're not using bioacoustics, in my view, you will miss species and you will underrate the value and importance of a site and miss potential environmental impacts on these species, for example. So you can work out what species are there better using acoustics or combining acoustics with traditional bird surveys. You can also get information in terms of temporal activity or spatial distribution that you can't get through using human surveyors. We did a study, yes, a decade ago nearly, on capercaillie in Scotland, and we managed to relate the numbers of calls we were recording at capercaillie leks with the numbers of birds that were there, so we can use it as a proxy for counting males by humans, and we could also track the levels of activity on a day-to-day basis. So the graph which showed us here just shows the number of calls recorded at a set of leks from one day to the next, and you can see that it goes up and down hugely depending on weather conditions. When it's wet, rainy and cold, the birds don't sing much. When it's warmer, the birds are more vocally active, and this can affect the survey resource that we get from traditional bird surveys in terms of likelihood of detecting these birds, even though they are likely to be present in the habitats we're surveying every day. They just sing more on some days than others. We also did another study at the other end of the UK. So this is on the Thames Basin Heath. So this is heather, sandy soils heather, which is protected at the European level as a special protection area for nightjar, Dartford warbler and woodlark. And so the UK government and the conservation agencies have a legal responsibility to monitor for these things, and we can record birds on the site. And so this is just a quick bit of nightjar call. So we can use that call to see where the birds are, count them up potentially. We did a latest study on a nightjar that looked at that ending of the call, and from the ending that is present now, it stops dead rather than coming to a slow stop. It's likely that that bird that was singing there was not in a pair, but was displaying still to attract females early in the season, rather than being a paired up bird later. So you can use the type of call to understand something of behaviour. Anyway, we did a survey at 44 locations across quite a lot of heathland to the west of London. We got some covariate data. So the top left is land cover map information. Also accessed Copernicus satellite data for the same area, and then overlaid that with the numbers of calls we were recording from these birds and recording how many days we recorded them on. So this map with the red dots and the black circles on shows where all the acoustic recorders were across the site. You can see some are just red dots, and we didn't record nightjar at those. And then the black dots are overlaid with the numbers of calls equals the radius overlaid for each of the 6 days that were recorded on site. So you can see that up in the north of the site, there's lots of activity and lots of days present. In the centre of the site and in the southern, fewer calls and present on fewer days. So we can start to understand occupancy and distribution of this species at a landscape scale, and also understand, it's sort of day-to-day levels of activity, and understand the habitat use across the site, and also obviously see where the birds are as well as where they are. That was published a few years ago. It also won a prize for innovation within the UK as well, as a good example of new approaches to monitoring. So birds dealt with, hopefully, very, very quickly. One potential area, and just going back to the start in terms of aquatic invertebrates, we can use recording equipment to capture sounds from below the water in ponds. We need a specialised microphone called a hydrophone for that. And although this area of science is very limited in terms of how many papers have been published, the first ever publication on ponds, temperate ponds, or acoustics in ponds anywhere probably, was in 2015. And so it's only 10 years old in terms of its development, but shows really good promise. And to try and get this used more within science and also within nature conservation, myself, Camille, and Jack Grillange produced a paper a few years ago trying to set up a draft protocol for assessing this habitat. And this was a sort of try to move away from traditional, or add to traditional survey methods with nets, and take a fairly simple recording equipment, use that within a pond, take a number of recordings around the edge of the pond, collate those with some metadata, and then convert those recordings into an acoustic index. So how am I doing for time? Okay, one more sound, because that's what we're here for. This is freshwater invertebrates in a pond in the north of England. And wild birds, mostly dawn chorus, aquatic insects, mostly evening chorus after it goes dark. And they can produce quite a lot of sound for small animals. So probably 2 different species of water boatmen, Corixa. They're doing their thing below a pond. And if we turn those sounds into an acoustic index, which is a fairly standard approach these days, which doesn't use a machine learning approach to try and recognize what species it is, but we analyze a sound recording just to look at the complexity and variety of sound within normally a 1 minute recording. We can turn that into a single number for that recording, and normally the more complex the sound is and the more that's going on, we give it a higher number. If it's not much sound, or if it's very monotonous sound, we give it a low number. And so it's almost a proxy for species richness in some contexts. We tested this out on about 25 ponds within England, and this is the biggest data set that's ever been published on pond recordings. Plenty of room to do further work on this, and got a reasonably good relationship between the bioacoustic index in this instance and a habitat suitability index, which takes into account a number of different habitat scores collated together for one pond, and seeing whether we can relate that HSI for the pond to the sound that are recorded there. And it does seem that those sounds taken as a whole within a pond habitat are a good indication of good pond quality. So it'd be nice to see someone else doing this and repeating it, see whether they find the same result or not, because it needs a little more, but good potential to use sound recording within ponds to look at pond quality quite quickly, quite rapidly, and certainly with a lot less of effort than trying to capture invertebrates and ID those all in the lab to effectively get the same sort of data out. So some species groups dealt with. Want to move on very quickly to habitats, and we can currently within the UK we're sort of struggling to get to grips with the new biodiversity net gain approach that's been put in place. So for any new development of housing, road, rail, commercial type of development within the UK, that requires planning consent. There is a legal requirement that we have to provide more biodiversity post-development now than was present there. And there's a numerical, quantitative approach to doing this assessment. The important thing for us in terms of acoustics, though, is that as part of this legal requirement, there is a need to do 30 years worth of post-development monitoring of new habitats that are created within this scheme. So we need to have solutions that give us valid, useful data to track changes in habitats over a 30-year period for every single planning permission that's given within the UK. So a big ask in terms of doing that. The current approach that the government's proposing is to go and do habitat map before development and after development, and do that every 5 years or so for that 30-year period. But we know and have known for the last 25 years or more that habitat maps produced by humans are not repeatable. And if you look at the little black and grey wedges on the left-hand side of the screen, this is the same area of habitat that's been mapped by different people, and there is pretty much no agreement between any of these maps that have been produced. So we know that we send humans out into the field to go and map the type and extent of habitats. They are not consistent with other humans and rarely consistent with themselves if they go back out and do it the next day, probably. So we need different methods for doing this long-term monitoring, and that needs to be remote sensing from satellite imageries or drones or other approaches such as acoustics. And we're currently working within PhD, Lancaster University, to try and get a decent approach to that. Another habitat that I'm just about going to finish on is the recent work we've been doing on soils. So a number of sound artists and other people have been recording sounds within the soil for a number of years. But the scientific study of sounds within the soil is very recent, very sparse, and there's been hardly any research work that's been done on this. And we basically can take the same hardware and software approaches that we're using for recording birds or bats or fresh water, and stick a microphone in the ground and record what's going on beneath our feet, because invertebrates, when they're moving and feeding, produce sound, and some invertebrates in the soil stridulate like grasshoppers and crickets as well. So we can listen to the signals they produce and use that to understand some of the biodiversity within the soil. Last sound of the day. This is a beetle larvae recorded in my garden. love the emojis going on the screen. Okay, not an exciting sound, but a useful one. From what we know, some of these large beetle larvae, rose chafer, garden chafer, and stag beetles, so Melanosa species, I think they are, all produce species-specific stridulation signals like this, so we can tell which species it is when we're recording. We've not recorded very many of them, so we don't have a vast library to do detections with, but that's something we're working on at the moment. And so we can record sounds like that within the soil, or use this acoustic index approach I was taking, and Marcus Mader in Switzerland has done some really good work, published back in 2022, where they took invertebrate samples from the soil, recorded it at the same time, and found that the acoustic complexity index is related to the overall species richness or taxa richness within the soil. And we can track diurnal patterns or dial patterns in the sounds that are produced in the soil as well. So within the UK, Northern Europe, temperate setting, soil acoustic activity is related to soil temperature. So it tends to be very quiet overnight, gradually increase during the day to a mid-afternoon peak. About 2 p.m.-ish, 3 p.m. In these coloured line graphs you can see here, and then drops off. So we can understand what's where, species richness or biodiversity, and something about behaviour by recording soil fauna. So useful information if we're looking at soil quality, soil health, and we're trying to develop this within the sort of regenerative agriculture setting to help inform farmers about their soil quality. We're doing that within a Innovate UK Farming Innovation Programme grant, which I've not got time to talk about. If you want to know more, please tap me up. I've got 3 months left to finish that project off. We've been in it for the last 2 years, and I need to write down what we found out before at the end of March. So just to finish off, if you are interested in guidance, there is guidance for bats and birds and other bits out there. The 2 Bibles, though, to go to if you want to understand more about good practice acoustics is Ella Browning's WWF report from 2017, Passive Acoustic Monitoring in Ecology and Conservation, which is really good scene setting overview of how acoustic monitoring can be used. If you want a bit more detail on how to actually implement it, then the more recent good practice guidelines for long-term ecoacoustic monitoring in the UK, it doesn't just apply to the UK, but we didn't want to get, ideas above our station in terms of claims for Europe or the world. But Ollie Metcalf, myself, and a fairly big raft of other contributors put this together 2 years ago now, I think, and that's available from me or from the web link that's shown at the bottom of the screen there. So please go and read one or both of those, and get some equipment and start doing some recording. And on that, I shall finish. Thank you very much.
Thank you, Carlos. I think we can move on to Jamie now.
Thank you so much, Carlos, for amazing talk, and I think really complimentary, because I'm not an expert in acoustics or birds or bats. I'm actually more of an insect and camera guy, but I'm going to talk to you more about the process of trying to roll out acoustics as a part of a transnational monitoring scheme, and really thinking about how to upscale acoustic approaches and what the considerations and limitations in that process. We're still only part along the way with what we call the Automated Biodiversity Monitoring Stations pilot, which is a Biodiversa Plus funded activity. And it's not just, we coordinate it here from Aarhus University, that's myself and Torge Hoyer, but we have many other partners, and Jarek in particular has given some material to help make this presentation. So we have 13 partner countries overall. So why do we need to do the ABMS? I'll try to cover that in brief. we have some alarming trends in nature, be it insects or be it vertebrates or birds, but often those trends are obscured by spatial, temporal, and taxonomic bias. So we have a lot of gaps in what we know, and this actually leads to a surprising amount of debate about the extent of what's going on out there, how bad things are, and also why those things are happening. What's the attribution behind it? So we need solutions to monitor that are scalable, because we need to monitor more. We need to monitor more species, more places, and for a longer period of time. So we need monitoring solutions that operate continuously in time and aren't just at points in time, but can go through time. And that's something that sensors are proving to be extremely useful for, to be really vigilant and out there the whole time collecting data. And another thing we need is approaches that are highly standardized. And unfortunately, sometimes automating things can help us to, I guess, keep the rules consistent during our monitoring and generate data that really line up. So those are three things that I think automation is promising. And the question we really have in the ABMS is, does this hype of automation and artificial intelligence convert to useful data under pressure and across borders? So pretty big question we've put to ourselves, and we're basically designing an entire survey kind of monitoring scheme to put this to the test. And I'm going to talk you through the questions that we've been trying to address in that process. So firstly, what sensors are we going to use? Secondly, where to put them? When and how are we going to do our recording? How are we going to manage the data that come back? And how are we going to process those data in a way that is actually manageable given the limited resources and time? And then, what next? So firstly, how do we choose what sensors we want to use? We got together as a group. We've also communicated with some other projects about the devices we were going to use. We needed devices for birds, bats, and nocturnal insects. That was the scope of the ABMS as it was designed. We wanted our technologies to be available, established, and reliable if possible. We want to be able to sample almost anywhere in the landscape if possible. So off-grid was an important priority, and also to be able to move those sensors around easily. And also we wanted to be able to have the sensors be maintained at most once a month. So basically we wanted to be able to leave something out in the field for a month and not be overly worried about whether it was stopping collecting data. So this is the ABMS station that we came up with after our selection of our tools. So it comprises an AMI system for insect monitoring, a TOMPS logger, and 2 song meters, one for bats, one for birds. And the solar panel there is powering the AMI system. So the AMI system is for the nocturnal insects. It's available. I think some of my partners would not be happy with me if I just stopped there, because it's been actually really complicated to get hold of these systems. It's very cutting edge technology, vision tools for insects. There are some other options, but they're not geared towards nocturnal insect monitoring. Basically, we've had a lot of trouble obtaining, in some cases, getting these devices to work. So I couldn't wholeheartedly say they're established and reliable. But once they're out and they're collecting data, they collect great data. They work off grid. They're not very portable because you need a big battery and a solar panel, and they can be left out for months at a time. The song meter, which is what we went for, it came to, are we having audio moths or song meters in terms of our discussions? And it was a choice between quantity or potential quality and reliability. And we opted for the latter. That was what we collectively decided was the best idea. And we found them to be, at least relative to the AMI systems, extremely easy to get hold of, off-grid and portable. We haven't all managed to keep them running for a month because some of the batteries we've gone for have been a little bit on the light side. So I think if we were to do it again, we'd probably make sure we get the batteries that would really give us that full month. So we got these sensors, and where do we want to put them? So this is basically a lot of studies are using these devices in either very bespoke research question-led environments, or just sticking out devices and collecting data in a sort of more citizen science style. We tried to really constrain a bit more where we're putting devices and why, and tried to go for this kind of stratified or systematic monitoring approach. So we decided we wanted to test these devices across forest, grassland, and wetland, and replicate that across our 13 partner countries. We wanted to survey high quality natural sites, so we aimed for Natura 2000 sites. We didn't always manage to hit that target, so only about 3/4 of our sites do we manage to get into Natura 2000, given the time constraints, and just having permissions and being able to quickly get these devices out. We opted for a nested sampling design, so we have more than one replica, at least in terms of acoustics, in each of our sites, which is useful to get an idea of local variation as well as variation across the different habitats. And we also tried to take it even a step further and say, can we even tell you more specifically where to place your device? So we kind of remove that issue of cherry picking where to place your acoustic recorder, which might maybe bias the data that you get back. This is something that was really quite difficult for partners to do. I'm sure it's partly because of the AMI trap being present at one of the locations at each site, which is way harder to just put that anywhere. But this is something that I find interesting, is that it was quite difficult to constrain where exactly the device would be placed, and our partners really needed that freedom to make the project happen. So what we ended up with is our 13 partners with 3 sites per partner, and you can see most of those sites across this map here. Really nice spread. So we have 1 AMI trap and 2 sets of song meters, so 4 song meters per site. 39 AMI systems, 156 song meters, so quite a few devices. And we tried to run these devices from May until October. When and how to record. So we wanted to try and get the maximum temporal resolution that we could, so the most frequent recording that we could, given the memory and power resources that are available. We wanted to aim for continuous monitoring, so not other than for bats, not focusing on particular periods, but trying to understand the phenology, but both through the day and through the season. We wanted to follow a standard protocol, and I can vouch for the report that you've just been shown. And I don't, I'm not part of the company that published it. I'm completely independent, and I found it to be very useful. And I really hope you managed to get one without in the UK on the end at some point. The people involved with that, good job. And these are the kind of parameters that we settled on. So we have a triggered system for bats. The things like the recording length and the sampling rate are worth kind of having a joined up approach to. And another point, we did use triggered recording, but we were quite cautious about that. So with the insect system, for example, we do have a motion triggered system, but we also want to have that baseline regularly recorded data so that we can understand if the trigger's maybe not working. We have an understanding that the trigger systems on the song meters are quite reliable, but I'm interested to know if anyone's tested that and found that not to be the case. We had a short season in 2024, but for those partners that managed to get their acoustic devices out, we got around 260,000 recordings per active partner. So lots of data coming in. But what do we do with that data? So we've done this. We've chosen one way to do this, which is we have data collection at a local scale. We have a centralization of raw data, and then a joint processing and analysis at a transnational scale. This is not the only way to do this. And if you want to think about how to design transnational monitoring programs and harmonize biodiversity monitoring across scales, there's this really nice report, Silva de Bozo et al. I recommend you check out. It's a Biodiversa report. So we have our partners collecting the data and then sending us raw data, which they do through manual retrieval of SD and SSD. Of course, this could be automated and done wirelessly in future, but at the moment, this is how we're working. We have in batches, we have this secure file transfer protocol transfer to a database hosted in Denmark. But we do ask our partners to retain local copies and encourage them to do their own parallel analysis and work, because that helps to inform our kind of more centralized pipeline as well, as we'll talk about later. So important things to retain are, of course, the metadata around each deployment. So which device was out, how long for, what was the habitat, these kinds of things, which can then be linked to the location metadata and to the file IDs within the database. So having this consistent naming conventions and indexing the files is super important. And as you could read about in the report that Carlos mentioned, try to match metadata field names to standards such as Audubon Core, Darwin Core. That's really a big step you can take to try and future-proof any large data sets being published. And this is what we're working on at the moment. While we're on data processing, I'm going to quickly show you. I know maybe you're not so interested in insects, but this is a model to detect insects in our AMI system, which has been trained by Asker Svenning, a PhD student working with Torga. And isn't it wonderful just watching all these insects be automatically detected by this AI algorithm? But yeah, I know it's not what we're here for, but I couldn't resist throwing it in. So processing data. Now we're talking about the acoustics. We wanted to use models that are available. So we need to be able to download the models and run them on a server independently. So they need to be open, at least in terms of running the models, hopefully in terms of the data and the training of those models. We want our models to be accurate, or at least we want to know where they are not accurate. So which species can our model not classify is something that I think is very useful when you're trying to use an automated data processing approach. And we want them to work quickly, of course, because that's the main advantage of using them in the first place. So what we've landed on, at least for our first iteration, is going to be BirdNet and Bat Detect 2 for birds and bats, respectively. Neither of these models are perfect. So the big thing here is we expect error in our process here, at least for the foreseeable future. We need to learn to work with the error and not just think that we're going to get perfect results. So how do we deal with that error? We need to understand where our model is failing to perform, potentially aggregate taxa in order to still use data if that's meaningful to do so. Obviously, we don't also want to throw all the detail out. We want to strive to get as much detail as possible. We can do some post-processing based on the confidence scores provided by models. But all of this is made stronger if we do some validation for a use case. And so this is something that we're really focusing on in the ABMS, is when we're using these automated approaches, how we need to also do a little bit of extra work just to make sure that we can make something sensible from that. So the next step in our chain is actually doing some validation. I'm going to talk a little bit about how to validate. So the key thing here is we want to correct for the false positives and the bias that our models present, and we can assume that those are going to exist. This is also going to help us to generate useful training data to inform the next generation of models. We want to be strategic and systematic about this. So we want to make sure that we get a systematic coverage of our data, but we might also want to be strategic. So for example, here's some data that Jarek has generated from birds in South Tyrol in Italy. He's put some of the birds through the BirdNet system, some of the acoustic audible data through the BirdNet system, and found a huge number of detections and actually a huge number of species. But we're fairly sure that all of these species are not present at the site. So he's shown us how you can increase the confidence threshold in order to get potentially species which are much more likely to actually be there, but then you potentially miss out on some species. And if we do our kind of validation by taking, for example, 20 calls of each species and stratify that across the range of confidences, then we can start to get this kind of confidence calibration curve. So this is the way of the confidence scores of the model are not that intuitive to use on their own. We need to calibrate them into kind of a probability of the species actually being there. And this paper by Wood and Kyle talks about how to do that, and that's something we're considering for the ABMS. And finally, I want to talk about false negatives. So ideally, we would take a stratified or random sample of all the recordings that we collect and send those for expert validation, and then cross-reference that with what the model told us. And this is a really good way to find out where we failed to detect something that was there. But that is also more time consuming. But I wanted to make sure that we had that. That is an important consideration, especially when some of our models might be prone to missing entire species because they're not in the domain of that model. So I've been flying through this because I know I've got too much content. I hope I'm not going too far over, but I wanted to quickly put some take-home messages. At scale, the availability of standardized equipment is crucial. So we've had some real trouble with the insect monitoring traps. The acoustics has been less of an issue. But the key thing is, as we really start to scale this, it needs to be, whatever tool you want to use needs to be available. And yeah, otherwise you're going to be limited in what you can do or how quickly you can do it. Old challenges of systematic monitoring and site selection are still really relevant for sensors, if not more, depending on how how portable they are. There are issues with some landowners might be concerned about the security of acoustic data collected on their land. These kinds of considerations are important. Centralized data processing may be a good model if we have local data processing case studies to inform that central data processing process. And data processing does not end with AI yet, so we can expect there to be errors in the models, and it's not about if, but how we carry out some kind of validation and make the results of our processing models sensible. So that was, I'm sorry for talking so quickly. I hope some of it came across. We have lots of partners in the ABMS, and here they are mostly listed, but of course behind this is a huge team of very talented people, and many of them are very much more immersed in acoustics than me. So thank you to those people who have helped me to learn a little bit as I've gone along. And yeah, I look forward to some interesting questions, and thank you for your time.
Great. Thank you so much, Jamie, and thank you, Carlos, for both of your presentations. Yeah, now the floor is anyone's, and anyone who has a question or comment or